And greetings. Oop, let me bump up my lights here. Okay. Audio working? Yes, audio check looks good. Welcome. Already finished off the coffee this morning, on to water. So today I would like to share what I've been working on, because it's a handful of stuff, and I thought it might be valuable to talk about some of this stuff, because you go along thinking you're doing well on a project, then you realize there's all this stuff behind the scenes that you got to build, you got to support, you got to maintain, design, make sure it's done properly. And it is a fair amount of work. And this is related to a Business Central AppSource app. And some of the stuff may be obvious, some of it may not, but it's just like one dependency after another that we've been dealing with. So with that, let's jump into it. So there are a lot of details that you may not necessarily think about or may not be obvious when you're building an AppSource app. And this is just a list of some of the things I'll touch on. Registration, external service access, Azure Functions and SQL DB or some type of backend database, license design and enforcement, library app maintenance, resource exposure policy, authentication and encryption. And I'll just list these here. I won't get into them today, but you have post-registration or post-licensing CRM and sales workflow, and then you have application support. So it's a pretty big list. Now, there are a lot of ways to tackle these things that I'm going to talk about, right? There are many ways to skin a cat, as they say, lots of solutions, lots of ways of doing this or accomplishing this for your organization and your app. So lots of different applications. So depending on what app you're developing, what it does, how it operates, some of these may not be relevant. You may do things in a completely different manner for your application, right? So depends on your use case. There are different customer bases. So my customers, say in the United States, my target market may have very different needs and concerns and ways of handling things and using my application than your customers in different countries or whatever. And if I'm planning on working with 200 customers, that may be different than your target market of 20 large customers, right? So depending on how many customers you're looking to address with your application, you may have very different approaches to doing this. You may have different priorities. So maybe your priority is application development, enhancing features, and you're just going to slowly backfill on the back-end processes to support that. Or maybe your application just doesn't need these processes because you're going to deal with this in a different way. Manual licensing, manual subscription licensing enforcement, things like that. Maybe you're using totally different technologies than I would choose for your solution. Maybe you have different technical skills. Maybe you have different internal technical skills. Maybe you're relying upon consultants or developers that are external who implement things differently. Totally fine. So all this is going to be different, different business processes, different risk preferences, and different support assumptions for your customers, right? So all sorts of context to this discussion. So, take it for what it is. This is relative to my small organization, my applications, my vision for where I think we're going to go with Business Central AppSource apps. So we'll see. It's unfolding, shall we say. So this is in the context of endless dependencies. And if you've done software development, it's like, oh, I just want to do this. Then you realize, well, that requires this. And then that requires something else. And then that thing requires 3 other things. And so you get into this dependency tree that just keeps growing and growing and growing. Eventually, you'll backfill with all the supporting dependencies. But it's really surprising how many dependencies there are. So you say, oh, I just want to sell an app on Business or for Business Central. Let's put it in AppSource. Well, how do we put it in AppSource? Oh, you got to deploy it, which means you got to be a partner. You have to have an account and all this other partner stuff to publish an AppSource. Well, okay, we figured that out. So how do we build an app? You got to figure that out. Well, that requires some design. So you got to learn that. Well, okay, we've designed and built and deployed the app. Well, how do we know who our customers are? Well, you might need some type of registration process. Okay, well, how do we get those customers to pay and buy the software? Well, you need some type of licensing and subscriptions. Well, okay, how do we do that? We need to invoice the customers so they can pay. Then we need payment processing, different payment methods, different countries, right? And then eventually you finish all that and you're like, oh, well, I need to support my customers. So I need a CRM, support, help desk, whatever. So long list of dependencies, right? At this time, I'm kind of in this stage. We've designed the app, we've built the app, we've deployed the app, and now we want to sell it. So we need customer registration, licensing, invoice payment processing, and CRM and support. So it's kind of where we're at, right? It takes time. We're kind of having to do this part-time as we juggle other day jobs, but it's happening slowly but surely. So let's talk about registration. If you've tried to work with AppSource, deployed an app on AppSource, you may know one of the frustrating things on AppSource is someone can install your app. AppSource claims to tell you that someone installed your app. It attempts to collect customer information for you, but it doesn't do a very good job for several reasons, which I'll just skip over. So we are, after seeing how that process works, how unreliable and kind of weak it is, we're going to go with our own additional in-app registration process. And so we want a more reliable way of collecting information about the customer, having them submit information to us, and we want to collect that on our own, completely independent of the AppSource process. Okay, so what does that look like? Well, we created a registration wizard. That allows us to be clear about our application, to be clear about our privacy policy, our terms and conditions, and to get the opt-in agreement by the customer for whatever that's worth, right? Legally, who knows? But at least we get some acknowledgement and we bring that forward to them and say, hey, here's our privacy policy. Here are our terms and conditions. Go take a look. Cool. Next, we collect information from the customer. So we allow them to submit their contact information, name, phone number, email address. We automatically pull some company information from their currently logged in company. They can edit it, may or may not be correct. And then we allow them to share, just spotted a typo, to share their Business Central partner information. Because if they're working with a partner, if the partner is helping them install and set up this application, we'd like to know who that is and coordinate with that partner and potentially share, say, partner margin with that partner. Happy to do that, right? So what's the BC partner company name? What's their email address? Who do we contact to work with them on that, right? Then we collect information about the environment. What's the environment name? Is this a sandbox or production? What version of Business Central is this being installed on? So we thought, well, if we're collecting information, let's go interrogate the system and pull this information back. And that gets submitted to our back-end customer registration system. Well, when we make that call to an external web service, what happens? Well, the user is prompted to approve or allow, external service access is the euphemism they use. So the extension is making a request to an external service. Do you want to allow this request? So Business Central is detecting that we're making a web service call to an external service, and it prompts the user to allow or deny this. And you can allow always, allow once, block always, block once. Well, I anticipate that this is going to be the source of several support requests. I don't yet know how many. I asked about this on Twitter, and there was a very low concern, was my impression. I didn't get much feedback, but it's like, what's the big deal? Well, if you have 5 customers that you've done this for, and they're PTEs or whatever, sure. You've worked with that customer, you have deployment processes, and this is probably a minor issue. If you're planning on publishing your app in AppSource and you want to have hundreds of customers, this becomes a different concern. And you will get support requests invariably. I would bet on it. I am betting on it. So how do we minimize the support issues around this? So that's number one. So we're going to have a pop-up on our wizard that says, hey, kind of like on iOS or Android apps. By the way, you are about to see a pop-up requesting access to your camera, to your contact list, or whatever the app, the mobile app, for instance, would be requesting. You're used to seeing that on a mobile app. I'm going to do the same thing in our registration wizard to say, hey, you're about to see a prompt asking you for external access. Please choose allow always. So we're going to guide the user to try to get them to make the right choice. Who knows if that'll work. Now, one interesting thing we discovered, if the user makes the wrong choice, allow once, block always, block once, based on our limited tests, we found something interesting in that we don't know how to fix that. So if a user said block always and okay, and it blocks the registration, we don't know how to advise the user or do a support call with the user to change that setting in Business Central. Now you may say, oh, Steve, that's simple. You just go into the extension and you flip the switch that says allow access. In our testing, that didn't work. Even after enabling that in extension management, our registration extension was still blocked. And then we tried uninstalling and reinstalling, and we weren't always prompted with this to correct the choice. So we don't yet know where this is stored. We haven't yet figured out how to correct this issue if the user makes the wrong choice. If you happen to know, I'm all ears. Please let me know. I'm assuming there's a way. I'm hoping there's a way, because if the user makes the wrong choice and blocks this, you got to solve it. And if uninstalling and reinstalling the extension does not solve it, that's going to be a real problem, which I'll kind of mention later. So that's a contingency, right? Not only do you have a support case, but you may be prevented from calling your web service if the user makes the wrong choice, right? This is the fun stuff you get to deal with. Okay, so our registration application is calling an Azure function to say, hey, this customer just registered. Great. So we're now thinking about Azure Function Security. So I've used Azure Functions, I prototype stuff. I've never put stuff in production, so I've never really dug into what does Azure Function Security look like? How do you configure it? What are the options available? How do you take security seriously with Azure Function? Well, so Eric Hogard, regarding the last thing, asks, it was turned on in the app and is blocked by environment still returns true. Okay, so I don't know if we're familiar with is blocked by environment method, but there is a method related to the extension that we can check, and we tried to change, we tried to flip it. It didn't have any effect. And so based on our limited tests, we're concerned that if the user makes the wrong choice, we don't yet know how to fix it. So we need to do more tests based on our initial investigations. Once we chose the wrong one, we were stuck and we're like, uh-oh, we have a problem. So it could be simple. There could be a solution, but based on our initial tests, we are not comfortable that we have an answer to resolving that problem. So we need to look into that. So let me just screenshot this. Is blocked by environment. And so 1, can we detect that it's blocked? And 2, can we resolve it? Can the user resolve it? Does it require a support call? Does it require something more advanced to resolve it other than flipping a switch in the extension management? I don't know. So little details, right? So Azure Function Security. So Azure Function kind of has some security by obscurity through obscurity by default. So when you call an Azure function, there's kind of a code that gets tacked on the end. It's some long, gibberish string, and that's kind of like an implicit API key. Well, additionally, there is an actual Azure function key that gets generated. And so I just noticed that today. I need to look into that. What does that do? Where do we supply that? Is that additional header parameter that we supply? So I just sent that off to my developer. More research required, okay? In addition to whatever Azure function provides, like we'll figure that out, we have chosen to go with HMAC authentication. So we'll do all the things we can find on Azure functions, and then in our payload, we are generating an HMAC hash based on our payload that will be supplied with the JSON payload. So when Business Central makes a call, it's going to provide the HMAC hash. Our Azure function is going to validate that hash. If it isn't present, if it isn't valid, if it is a replay attack, if it's more than so many minutes old, we're going to reject that request. So we're doing that to kind of a combination of authorization, authentication, and security. In addition, we have some additional steps we're going to perform on the payload to validate it. Is this a valid payload? Now, someone could, identify what payload we're sending in theory. They could mimic that. So that's of limited use. But if someone attempts to send in a random payload or a bad payload, we're going to try to detect that and reject that as well. That's obviously of limited value, but it's an additional step. We are using SQL parameterization for all of our communication between Azure functions and the Azure SQL DB in the hopes that that reduces the risk of a SQL injection. And so that's our limited understanding of how to mitigate SQL injection attacks. It's not perfect, but it should greatly reduce the risk, okay? And we're doing some other things on the SQL side, which I'll get to. But I have some questions like, how do you do logging in Azure functions? And I now see that there is monitoring here, and it does appear to have some type of logging. So we need to look into like, how does that work? What does that look like? What type of auditing is there? What does breach mitigation look like? So if someone starts banging away against my Azure function endpoint, will I know? Will I get a notification? I'm assuming not. If my calls against the Azure function, if the calls against the Azure function go from 100 a day to 10,000 a day, how do I know? I want to know that. Something's wrong there, right? So if I see a spike in calls, if I see a spike in bad calls, how do I monitor good calls versus bad calls? I think that needs to be custom. So all of those questions we're looking into of how do we harden and secure our Azure function. We have chosen to use Azure SQL Database. I've spoken to someone else who has chosen to use Azure Blob Storage due to performance. Makes sense, but my developer and I come from the on-prem client server SQL Server environment, so we know Azure SQL Database, right? It's just like old school on-prem Azure SQL. So we're going with what we know for now. there are some, performance downsides, complexity downsides potentially, but, we at least know this. It's the devil you know, right? So we're going to go with store procedures for all access to our Azure SQL DB, no direct table access to theoretically minimize the surface attack area that we have on our Azure SQL database. We're going to have restricted Azure SQL logins. So anything accessing our Azure SQL database will be a specific user locked down to only have permission to get to the objects that it needs, primarily being stored procedures, no direct table access, right? No admin access. And we'll be using Azure SQL database, so we'll have the benefits of that. Automatic backups, need to look into how that works. If we had to do a restore rollback, how do we do that? If we needed to download a backup, can we do that? Geo-replication, if we have downtime. If there is an attack, how do we mitigate that? How do we, come up online with a second instance? I don't know. How quickly can we switch over to an alternate Azure SQL database if we had to? And for context, all this is going to be set up in a separate production Azure SQL environment. So from scratch, completely isolated Azure SQL environment. It'll have nothing to do with our main Office 365 environment, our main Business Central environment, completely isolated production tenant just for this purpose. And just like Azure Functions, on the Azure SQL side, what logging is available, what monitoring, what auditing, how do we detect a breach, an attack, crazy weird volume errors, things like that. I want to know when that happens. So what type of notification can we have in case there's something strange going on? I don't know the answers to any of that. I never really set that up on-prem either. So this is all new, not only for SQL monitoring, logging, and notifications, but also Azure SQL database notifications. Okay, so customer registers, that gets submitted to our Azure function, that gets submitted to our Azure SQL database. We have a registered customer, and as part of that, we generate a license key. And so by default, new customer registers, they get a trial license key. So what does that look like? Well, we had to design a license. We're generating a license, so we had to come up with a license format. We initially worked with a delimited value, so just a string delimited with a set of parameters that would represent, say, who the customer is, their tenant ID, which product they're using, what an expiration date is. But then we realized, well, what if we want features? What if we want a trial mode, true or false, other parameters in the license to help that product understand the state of the customer's license? So then we switched over to JSON. So on the fly, before deploying, we said, well, let's stop, let's fix this. So we switched over to a JSON payload to give us more flexibility for this product and future products. And as part of that, we have encryption. So our license is fully encrypted. So that JSON payload is just a glorified string that will be encrypted in transit, at rest, and it'll be decrypted when it's read and then parsed in order to determine what the customer's license status is. So we added trial mode as a parameter so that we could have trials so that the application can read the trial mode flag, display messages to say, hey, thanks for trying our application, and pop up, instructive tips, the little tool tips that pop up or teaching tips that pop up. And we could also say, hey, thanks for trying. Your trial expires in 15 days. And that trial mode notification will be different than a paid registered customer who has a subscription whose subscription expires in 15 days. So we'll just have this pleasant reminder for trial mode customers, but a paid customer whose expires in 15 days will be a different message. Hey, you're about to expire. You really need to contact us to renew. And we want to have a different mood around that, right? Multiple products. We need to support multiple products in the future. So we need to make sure to have that embedded in our license design. We don't have this need at the moment, but other people activate features. So maybe you have a big app and there are 10 features and the customer only needs 3, so they'll pay for those 3. So you'll need feature activation in your license key, presumably. And other people may have usage-based licensing. So maybe it supports tiers. So 1 to 500 transactions, 500 to 1,000, more than 10,000 transactions, and the customer pays based on their usage. Or maybe it's metered licensing, like, okay, you'll be billed on how many transactions or checks or payments you process a month, and we'll bill you each month for that. You need to monitor that. So all sorts of scenarios for licensing, right? You got to figure out, okay, how do you design a licensing model and a license structure that will support your business model, your use cases of your application, and how customers might use them? So great, you've got your license, it's generated, it's encrypted, it's stored, whatever you're going to do with that. Well, how do you enforce your license or your subscription? So once a license is generated, do you store that locally in the customer's Business Central environment? Or is that just an online license check and that just gets stored in memory for the user session? Maybe some pros and cons there, depending on anticipated scenarios that you may run into. Is it online retrieval only? Or if you store it locally, maybe if there's a communication issue with your Azure function, do you need a backup method to allow the customer to paste in a license key? I don't know yet. I'm hoping online license validation works fine, but I'm fully prepared to need a fallback of a license entry page, right? That's what we would do in the on-prem world. And then once you validate the license, like how do you read that? How do you validate it? How do you ensure the license integrity? We do timestamp checking. We have hashing and encryption of our license key to just validate the validity of our license key. And when it's starting to expire, like how do you approach that? Do you notify the user? How do you let them know that they need to renew? And then if it expires, what do you start to do? Do you block certain features? Do you cripple the application at some point? Do you not let them open pages? Are things read-only? Can they not process? Do you disable job queues? All that discussion, how do you figure that out? And how do you code that in Business Central? And how do you code it so that it can't be easily bypassed with a PTE? If you have a clever partner who's like, well, maybe we can get around that. Maybe they can reverse engineer your process and figure out, well, if we disable this, this trigger, maybe we can bypass the licensing. So how do you try and mitigate those concerns? And then we are choosing to use a library app. That's an AppSource term. It's a library app for our registration application. So we have application A, and it has a dependency on our library app, which is our registration application. So when we go to deploy that, we're going to release, say, version 5 of our application A with version 1 of our registration app. And that's all fine and dandy. But then we want to release application B, version 1.0. And maybe we had to make an update to our registration app to support application B. So we're going to release a new version of registration, version 1.1. Okay, if we release version 1.1 of our registration app as a library app on AppSource, will that affect our first application A? We don't think so. We hope not. But it's getting deployed. A new version of our registration app is being deployed as a library app. And my assumption is that's a single central app in AppSource. So it'll be shared across our application A and application B. So if a customer installs application A after we've deployed application B with version 1.1 of our registration app, you following me so far? Then, okay, what happens to application A? Is it using 1.1 of registration? Or is somehow version 1.0 cached? I have certain assumptions. I don't know. We're going to test that and we're going to have to see. But the only way we can really test it is to deploy through AppSource and see what happens. So we're ready for stuff to blow up and break, but that's the only way we learn. And then once we deploy a new version of application A, presumably we need to redeploy with a reference to our 1.1 registration app as a library app? That's my assumption. Don't know. But we're aware of the potential issues. We're expecting complications, and we're aware that we need to be careful to avoid breaking changes in our library app. So if we're deploying a new app, if we're deploying a new version of an existing app, we need to make sure we're coordinating with our library app. We may have some deployment timing concerns. We're going to have to learn that process and figure out what AppSource wants, how it works, and what goes on behind the scenes. So then there is Show My Code. And this is the old name. It is now called Resource Exposure Policy. Quite the mouthful. Quite the mouthful, and that is replace Show My Code. And it has 3 properties: allow debugging, allow downloading source, include source and symbol file. And in our case, for our AppSource app, for our registration app for sure, we will be setting all these to false. And then there is additionally the non-debuggable flag. And from what I read this morning, that looks like that is kind of in addition to the allow debugging. So I think if I read right, you can have allow debugging set to true for certain code. That's the default. But if you want to have some things private, you can set non-debuggable to false, or you can set non-debuggable in your code for certain methods or certain code units or whatever objects in order to limit debugging for those objects specifically. So looking into that. And then there is also the access equals internal property. So we're going to look into that and use that liberally when possible in our registration app. And we need to understand where we should use that in our main app. So that's what's going on there. And I have links at the bottom of the slide here. And if you've seen Game of Thrones, you will be familiar with the white wall, the Great White Wall, whatever they call it. And that was in the Game of Thrones series, that was their great defense against the White Walkers and the bad guys. Well, that's kind of like what Show My Code is in Business Central for my licensing and registration process and license enforcement. If this is somehow breached, or if someone finds a workaround to this, or if there's some way to extract our code or view our code, as far as we know, there is no way to mitigate against that. And if you've seen Game of Thrones, you know what happens to that wall and how quickly it topples. So it's a very thin protection that is preventing someone from extracting our code, seeing our encryption, seeing our hashing, seeing our Azure functions, seeing our licensing scheme, license enforcement scheme, and trying to figure out a way to work around that potentially, right? And this assumes malicious intent. So it's a minority, but it is real, I can attest. In addition to all of this, or as part of all of this stuff, we are implementing encryption and authentication. And as I mentioned, we are adding HMAC authentication to our Azure function calls. So that uses SHA 256. And we are using encryption for our license key and other elements. And that's AES 128 on the Azure function side, which is CBC and PKCS7 parameters for that AES. And we found a Raindoll code unit in the Business Central encryption code unit library that was contributed via a pull request. And we were able to match that against a specific AES configuration in Azure Functions with .NET. So it is possible to have pure, proper Azure AES in Azure Function and Raindoll with 128-bit block size and 128-bit key in Business Central. Now, it does require you to understand and carefully manage your salts and your initialization vectors for all of that encryption. So we're having to manage all of that for every single customer that registers. So every license key will manage that separately. So yeah, that was a learning process. And then we learned a little bit about base 64 encoding. The rain doll in the Business Central encryption is a little quirky with how it wants certain things base 64 encoded, and it's not always clear when you base 64 encode and when you're sending in byte arrays. So that was a little tricky. We had to figure that out. So yeah. So we had to manage secret keys, and that's embedded in code. Like, I don't know a great way around that. You could say, well, there's Azure key storage, but if you look into Azure Key Vault, I believe there's some limitations, complications, and it's a little heavy. So for now, we understand those risks. And then key rotation. We're prepared that if we realize there's a problem, we're going to need to do a key rotation. It's going to be an absolute mess. We're going to have to reissue license keys. We're going to have customers upgrade. So what does that look like in case we have a known breach of our encryption? And if someone circumvents this and uses a Business Central application without a valid license or subscription, can we detect this? I suspect we can, because I think it would be difficult to completely disable all application insights telemetry. And so I suspect there's a way, at least through App Insights, to potentially detect the tenant ID, and we would see some activity with an unknown tenant ID and potentially know that something strange is going on. Can that be circumvented? Maybe, but there is probably going to be a challenge to strip out everything. But if they can get access to the source code, right, all bets are off, right? So it's like, if someone gets physical access to your PC, no security in the world is going to prevent them from getting access to your information. So you may say, Steve, well, why are you going to all these lengths to try and do all this stuff and protect this, and complex licensing and encryption and all these threat models? Well, I sell a .NET application. I've mentioned this previously. It's a .NET framework application for on-prem. Well, at one point, a partner requested a trial. Never heard back from them, completely forgot about them. Well, years later, I got a support request from a customer. Says, oh, yeah, we're having a problem with your application. We're getting this weird error. I'm like, that seems kind of strange. Like, what's going on? So I said, can you send me a copy of the DLL and files for the application that you're using? And so they did. And I did it subtly so that they wouldn't catch on, because the file names didn't make sense to me and the application name was odd. And so it turns out that that partner that had requested the trial had decompiled my .NET Framework application. They had removed the licensing that I had implemented there. I don't know if they implemented their own. I didn't even check for that. But they then resold my application as their own under a different name. So they called it something different and they sold it to their customers. And the only way I caught it was an unknowing customer wasn't in touch with their partner or didn't know to contact the partner. They Googled me, they found me, and they submitted a support request. And yeah, that's how I figured out that a partner had essentially stolen my application and resold it. So it does happen. And this was a Dynamics partner, right? Like, it's $800, yet they went to all this effort to steal my application. It's very strange. So it does happen. And unfortunately, yeah. So just since we're dealing with security and threat models, this is one threat model. So we're putting in a few things to try and mitigate that. It's not going to be perfect. It's not going to be bulletproof. Someone very clever, I'm sure, can circumvent it, but it is a real threat. It does exist. So then you might ask, well, why all this concern around security? And this one should be fairly obvious. In just a few minutes, I just pulled up some headlines. This is just the last week, right? So all these headlines are from news articles from the last week. And so if you're not sure on why you need to be very serious about security, yeah, you might be in trouble. So this should be obvious. We are assuming an attack on our application, on our registration, our licensing, on our customer information. And so we are assuming an attack, we are assuming a compromise through known vectors into our systems, and we are discussing, okay, how do we mitigate the risk, limit the damage should this occur? So if someone is able to compromise our Azure functions, what information are they going to get? Will they get any customer information? Would it be considered a breach? And based on our design, we think no. They'll only be able to get a license key. They won't know anything about the customer. We're not disclosing that via any of our Azure functions. So our other backend systems, we're going to have to secure those, but this component we think is limited in terms of exposure. So we're not perfect. We're not experts. We're not pen testers. We're not red teamers. We're not black hats. So, we don't know. And this is very difficult. If these organizations were unable to secure their environments, we're at risk. We're going to assume attack. We're going to assume a compromise. And so how do we intentionally limit the damage from such a compromise? So that's the thought. So those are just a few of the housekeeping items that we are working on related to our AppSource application and the effort we're going through to backfill, to build the infrastructure to support our initial AppSource app and future AppSource apps for customer registration, licensing, billing, support, the CRM sales process, etc. down the line. So it's a handful. And with that, good luck on your AppSource endeavors, and talk to you later.
Good morning, sun. How are you? Skies above. Jeeps